manage and run the agent functions that you're going to implement and use through MLflow. You can also then have them managed through Unity Catalog. So Ben will go into that in depth. And then talking about MLflow Tracing, what people are doing with it, how it's primed and ready to be used for GenAI and agentic workflows, and how it really helps. And the team here, Yuki and Daniel, are going to talk in depth about tracing and make sure people are aware of what all the cool stuff that's here that's available for people in MLflow. So let me just hand it off to Ben.
I think this is a perfect opportunity to talk about MLflow Go. So
Go
take
for
it
it.
away.
Sure, sure. Happy to take up the time. Um, I came on here because I have a team of people. I run a big open source program office, and I have a team of people in there who have been working on a little project to make MLflow's experiment tracking faster. And it's called MLflow Go Backend. And with the help of Ben, we've just gotten it PR approved to sort of make it official and invite people to come and take a look and use it. Should be a drop-in replacement for MLflow's normal experiment tracker, and it should just be faster. So I'm here to sort of invite people to check it out and to tell us if it sucks or if it's just working magically faster, and also if you're keen to help us develop on it, to join us. I'll drop some links in the chat here for what it is, but thank you very much, Ben, for helping shepherd the project forward with my people.
Yeah, there were a few delays, mostly because of PyPy reserved namespaces and some issues, but yeah, I can confirm. Check it out. It's seamless. So the APIs that are supported are the heavy hitter ones. It will be significantly faster than the standard MLflow tracking server. And for those APIs that you don't really need sort of the high frequency communication, it'll default back over to the standard MLflow tracking server. So you shouldn't see anything that impacts your normal use of MLflow. Uh, it's just sort of transparent and it's awesome. It's an officially sanctioned MLflow project, so it's actually in the MLflow domain. So if you go to github.com/MLflow, it's in MLflow Go.
Yeah, yeah. Thank you very much. You hit on some points that I should have said. Yeah, yeah. Really pleased that this is mostly just an invitation to everyone. We'd love feedback. Tell us how it is. So, thank you, Yuki, for chucking the link in. You beat me to it. So, thank you. Yeah, and that's it. That was just a public service announcement.
Brilliant. Thank you so much.
All right, I'll be extra quick through my slides here and my presentation.
Right on.
Hi,
You,
everybody. I'm Ben. I'm one of the MLflow maintainers. And what I'm going to be talking about today is what is this Unity Catalog AI thing that just got released a couple of weeks ago? What can it do for GenAI, development, application development, and the actual application authoring experience, and what does it look like to actually build with it? And at the end, I'll go over a really quick, demo that'll actually show how this interfaces with MLflow and how the synergy is. All right. Unity Catalog AI is composed of two separate components. The first thing is a client, and that's its own, installable repository from PyPy. And this client allows you to do stuff like CRUD operations as well as execute functions, but it's the interface that these toolkits are going to use to allow a GenAI agent to execute a tool that's registered as a function within Unity Catalog. And the other part of this are the toolkits. Now, for every GenAI authoring library that we do an integration with, there'll be a separate package for that toolkit, and it all has a shared namespace, so it makes it a little bit easier to import stuff and deal with things. It feels like a unified experience. So as I was saying about the client, we have stuff like, helper utilities in there with creating catalogs, creating schemas, being able to do all your CRUD operations. But we also have this ability to create Python functions. Instead of having to do things in the native Unity Catalog way, if anybody's familiar with Unity Catalog, you would normally have to define a Python function within a SQL body. The create Python function API allows you to just define a normal Python callable. There are some caveats to it about, you have to provide some metadata associated with the callable definitions, such as type hints are required, and you actually need a doc string that's in Google format. But provided that you do that, we'll be able to register that as a UC function that can be called pretty much anywhere. You can just directly call it through SQL. You can define it as a UDF to apply over a Spark data frame. And you can also just embed it directly into, via the toolkits, a callable function for an agent. The other part is the toolkit aspect. So that's interface is just basically the UC function name, which is catalog.schema.function name. That goes into the registration of a toolkit, which gives you a tool definition. That tool definition is used directly within the integrated libraries. So we do the translation for you to make sure that all that stuff works. And then you just invoke your agent. And it will autonomously, when it needs to, call functions in order to get those sort of answers. So for the initial integration list lineup that we did for 0.1.0 release a couple of weeks ago, we have OpenAI, LangChain, LlamaIndex, AutoGen, CrewAI, and Anthropic. Those are the first 6. There's 6 more on deck, going to come out over the next month or so. But these are the core ones that we started with. Now, the big question everybody might be wondering, why did we build this? There's, some fairly obvious things and then some not so obvious things. But when you define that agent or that tool that you're going to be using for an agent, there might be sensitive information in that function definition, or it's accessing data that you don't want just anybody to be able to access, but you specifically want your agent to have access. So providing fine-grained access control via Unity Catalog, it's a huge benefit. The one that is most germane to, software engineers is code duplication removal. So you don't have to define the same function for multiple different applications that you might be writing. You just define it once. It lives in Unity Catalog in a managed service, and you can use that just by referring to its name across as many projects as you might want to use it. The other thing is simplified agent application usage. So instead of having to define in their format, if you're developing in multiple different library formats, this can get kind of complicated. You're like, oh, how does LangChain do it? Oh, now I need to use OpenAI. Now I have to construct this JSON payload. We just solve all that for you with Unity Catalog AI. So it's very simple. It feels the same everywhere that you go in order to use tools. And then that unification, saves a lot of, cognitive load on you while you're building these things and testing them out. Testability is another thing. A lot of these things are deterministic. These functions that you're going to be defining in order to combat that whole making stuff up that GenAI LLMs like to do. So if you want an exact answer to something, you want a deterministic result, you can define this function and then test it via unit test to make sure that it's doing exactly what you'd expect it to do. And the last one, which is most important to us, is it's got direct integration with MLflow Tracing. There's recent things that are going to be coming out in 0.2.0 that allow for special tracing to occur on retrievers, so that we can make sure that we have a special handler for that, and MLflow Tracing will display it accordingly. So we're going to go to a quick demo real quick, and I'm going to run through this kind of fast, but we're going to look at how does this actually look.
Yeah.
So first thing here, when you're going to be creating a client instance, we need to define, a configuration of where is Unity Catalog running. And this is specifically for open source Unity Catalog. We create that client, and then we build the Unity Catalog function client, which is from Unity Catalog AI. And for this example, Expanse fans, the catalog is named Expanse. The schema is Rocinante, and you'll see why in a moment. In order to get functions to be written, we need to make sure we have a catalog and a schema created. So that's what this is doing. We have helper functions within our client API that make this much simpler. The open source Unity Catalog client is an async API, so it's a little bit more complex. So we create synchronous API helpers for you for this. And after running that, we can see that we did create a catalog. We did create a schema named Rocinante. It's got all of the information associated with it. And now we can just start defining functions. And instead of having to write SQL bodies embedding Python code that we can't really verify unless we go through a long dev loop process, this allows us to just write the function as we would write it in any other code. So this one, I want to calculate or provide a function that will allow us to calculate the recoil force for when the keel-mounted railgun on the Rocinante fires. How much do the engines need to compensate for? Another function, when we fire that railgun, how much kinetic energy is imparted to a target? And another one for fans of the belters and people who like to fling asteroids at planets, how much energy is imparted when an asteroid strikes? So we're getting like asteroid mass, impact velocity, and we can get the amount of joules returned. And then laser weapon effects, another just fun thing. How much energy is imparted by a laser weapon on a target? So after we define all these standard Python functions, all we have to do is call our client to create the Python function. And what we're actually passing is the callable itself. We're not passing any other reference, just here's my function definition. I need to pass my catalog and my schema, and that's it. All those are the three things that you need. If you want to replace something in place, be judicious about this. You are going to replace it forever, so be careful when you use that. But by default, it's false. And that's all that's going to be required, and it'll register it in Unity Catalog in the format that Unity Catalog needs it. And when we want to execute it, we can pass in that function name. So estimate laser weapons effects based on that catalog and schema. This is the Unity Catalog naming convention. And we pass in our parameters as a dictionary. So each of those arguments that we defined in that function signature and some values. And these are strongly typed, so make sure that they are the right appropriate types that are expected. But you'll see with a function information definition, we're actually getting all of this from your type hints. That's why we need to do that, why those have to be supplied. And those will be registered in UC. And we actually get a result here. Get that value result, very large number. And we can execute the other functions as well and get sort of similar results. But where this becomes interesting is when we're actually going to build an agent. And this section here at the top is very similar to what we did in the last one. We're just basically creating a client that can interface with Unity Catalog. We're defining all of the functions that we're going to be using to get all of their names. And these are the actual string names, catalog schema function. And here it is, just a bunch of strings that list out, here's where these functions are in Unity Catalog. Now we can actually start setting up MLflow. So we can connect to our open source MLflow server. We can set an experiment named Rocinante, and we can turn on auto logging for these. And this will automatically enable tracing for everything that we're about to do. So we're going to get this not only in the MLflow UI within the experiments under the tracing tab, but we're going to get it in this notebook as well, which is kind of cool. So for this first example on LangChain, standard imports for doing stuff with LangChain. And here we're going to get our instantiation of a LangChain toolkit. And what this is a UC function toolkit. I'm just aliasing it because we have multiple things in this notebook. But this UC function toolkit, we're going to provide in the names, those string names of what we want tools to be called and how to fetch them from UC and the UC client that we have available. We then access the tools themselves. The return from this toolkit is a bunch of metadata as well as the tools. But for the libraries, all we need are the tool aspects. And from there, we can just do standard GenAI stuff with LangChain. We're going to create a system prompt. So we're going to be talking to Amos, chief engineer on the Rocinante. He's a pretty funny guy. And we're going to be using GPT-4o Mini to assume Amos's personality. And we're going to assemble the chat prompt template. We're going to create a tool calling agent where we're passing in our LangChain tools directly. Those are the ones that we just defined from the UC function toolkit and our prompts. And then we're going to create an agent executor, which is going to take in that agent, the tool definition again, and want it to be a little bit verbose so we can see its chain of thought. And we're going to ask a question about the keel-mounted railgun. We throw this thing, we fire a 50-kilogram tungsten slug and we charge it up for 19.5 seconds. And this is the actual exit velocity from the muzzle. How fast are we going? And we can actually see that what it's doing, this agent executor chain knows based on the information provided, it needs to call this function. This is our Unity Catalog function. And it knows because we've given it metadata associated with what arguments to call and what types to provide, and it's going to generate that. Our toolkit is then going to actually execute that on Unity Catalog. It's going to fetch the function definition. It's going to execute it in its execution environment, and it'll return the answer. And that's what it is. It's going to give the average force and the impulse in these numbers, and then the agent's going to get that in and start thinking about it. And then it's going to respond as Amos kind of would. So make sure your thrusters can handle that, or you might be playing a game of how far can we fly backwards. Haha. But exciting aspect of this is we get this MLflow UI that the team built. People are going to be talking about right after this. And we can see everything that was happening there. We can see the actual function call that was made to Unity Catalog, what its results are. Like here are the inputs, the parameter arguments, and the outputs from Unity Catalog. So all of this gets natively traced within MLflow, even though we have something that's executing in an external system that we also control. We can even do more complex stuff. We can use stuff like Crew AI's integration, where we can do some pretty crazy stuff, like create agents for every member of the crew. So we got Amos. We can give him a backstory. It tells him like who this person is, who this agent is going to assume as their identity, and give it some goals. Like, here's what I want you to do, and these are the sorts of questions I want you to answer, and it'll determine which agent to send the user input questions to, and then each of these agents are going to talk to one another. So we got the captain, James Holden, Naomi, Nav and Systems. We even got Bobby. And we can create this entire crew, giving them the descriptions for these agents and their actual agent definitions. And within that, we're also giving it the ability to understand which tools it can use. So we don't pass it to each individual crew member. We give all the crew the ability to use these crew tools, which are from our UC function toolkit. And that's all it is, just one line to configure this agent so that it can access these tools. I'm not going to go through all of this, but it's a very long conversation that this agent had, or this group of agents had. But they're going to go and evaluate first before any human input, before I even get to answer, ask it a question. They're going to go and check to see what tools do to learn them. They're going to look at the tool definition. They're going to actually fire off some data to it, check the result, and they're going to basically talk amongst themselves to say like, oh, we have these tools available to us, and this is what the results are. So it's sort of like a self-validation thing. So eventually you do get this, human prompt that you can type in a question, which I did above, asking about an asteroid impact. And this is the series of agents that are talking about that and realizing that they need to call some UC functions. And you start seeing stuff like the captain's going to call the function and then talk about what its results are, pass that on to the nav system engineer. They might call the function as well, just to validate, or they'll pass it with different values to check to see what the results are. And eventually you finally get an answer from the end of it, which will be what you actually asked, with all of that tool information in there. So that's a Unity Catalog AI and MLflow integration, and showing like, this is how complex this particular agent is, how many things were going on. Lots of calls to the LLMs, lots of calls to Unity Catalog to actually execute functions, and we can see it all here in the UI in order to do debugging or whatever else we need to do. And that's it for me.
That is awesome. Thank you, Ben. Team, do we have any, Ben, would you be open to taking a few questions right now? Just any little follow-up notes or anything?
Sure. If anybody has any questions.
For the end of the conversation, if you'd like. But if people have questions right now, we'd like to throw them in. Either chat them, or if you'd like to come off mute and just say it out loud, please do. I've got one from Nathan.
Yeah, hey, thanks, Kobe. Ben, your references there to your inputs in your agent list, are those just index correlated between the names of the crew and the tasks that you're giving the individual crew members / agents? Is that how that function was called? Just like by positional argument there?
For crew AI?
Yeah, you had a list, you had an input with a list of crew members, and then you had a list, I believe, of tasks defined in
Hmm.
the following parameter. So are those just mapped positionally to the crews of the previous input? Like the individual is you know understand what I'm saying? Are those just index based?
No, you actually pass in the agent definition into the task. So
Oh,
like
okay,
depending on
okay.
a task, you say like this task I want to be handled by Amos or by Holden or whoever, and they'll
Got it, got it,
assume
got it.
that role based on their agent definition and their backstory and like what their goals are. So you can
Okay,
get
so they're
really
they're
complex
explicitly
stuff with
paired.
this. What's that?
They're explicitly paired.
Yeah, yeah, yep. Yeah,
Okay,
you have to
sweet.
define that.
Okay, cool. Thanks, dude.
Mhm.
Got a couple of the questions in the chat.
Jules asked, what LLM is being called
I think I saw Jules.
for
Yeah.
Crew AI? That was 4.0. It's the default for the Crew AI version that I'm on.
And then Bruno's question, does Unity Catalog kind of track versions of register functions?
Uh, you can't really track the versions of the functions. The functions are just defined. Um, so naming conventions generally is how you would handle that.
And I saw your thing about replace and like so like if you reuse the exact same name, you like you can just go ahead and replace one function with another one, and then the ones
Yes.
that replaced. So if you have like say like for example like this is the production name that I'd like to use, then
Mhm.
you iterate and test with alternate names like you said with versioning or something like that, and then copy to the canonical name when you're ready, right? Something like that.
Yes, exactly. The recommendation is use a different catalog for production.
Yeah,
So you
yeah,
have like a dev catalog, you're playing around, and then you want to move over to prod. Um, yeah, and have like a staging catalog as well.
yeah, right on. That makes sense. Let's see additional questions we have in here.
Anthropic was
I'll
mentioned as
call
an
that a topic.
integration. Does this trace MCP server calls? Not sure what MCP server calls are.
Mike, do
Sorry.
you want to clarify?
I'll try to get back to that.
Yeah,
I'll look it up.
we'll circle back. Yeah,
But it's
we'll keep
basically
it.
the main API for Anthropic. So the Anthropic SDK, your main interface, if it's supported by that SDK, you can integrate with it.
Model control protocol. He sent a link for the docs for that. Um, but yeah, cool. That's good. And then Andreas's question here: looking at costs, you listed a large number of LLM calls. What approach would you propose to limit costs in this scenario?
Maybe don't use Crew AI. It's an it's an awesome library, but it can get expensive. Uh, a lot of people use it for like direct human interaction in a notebook environment. It's excellent for that. And if you have a sufficiently complex task that you can't just solve by having a somewhat simple agent that's just like, oh, a couple of LLM calls with some tool calls. We have a number of like, customers at Databricks that use Crew AI for very broad problems that are also very deep and complex that require a lot of nuance to them. They're not doing sci-fi, spaceship crews for answering silly questions like I do. They have roles for sort of one is assigned to fetch data from Unity catalog tables. Another one is assigned to fetch, function call data that's doing stuff like operating on that data. It's very complex to build those systems in some other frameworks. So Crew AI makes it a little bit easier to do that. And it's kind of fascinating to watch it run too.
Yeah, maybe this is related to my other question. You mentioned that each agent basically can call all the functions, or the same function can be called by multiple agents. Could you speak about a realistic scenario where you would segregate these things and have um, different sets of functions limited to different agents? Are we talking about some kind of information separation, or kind of clean room situations, or where would this become necessary and useful?
Yeah, you can do that with Crew AI, but it would make the demo look much more complex. That's why I didn't do it. It's just more
Yeah, I
code
know
to
that.
write.
Yeah, I'm not talking about the demo. I'm kind of thinking about business applications and wondering what that might look like. Like, what would a scenario look like that is the scenario where you need this?
Uh, I'm not sure of all the different use cases, but I know it's something that people do. So if you wanted sort of a like you can uh, you can set up your definitions for per se for crew AI to be collaborative, which is what I did. It's kind of a crew working together and bouncing ideas off, or you can make it antagonistic. So there's agents that don't trust anything that another agent generates, so that you get towards a validated answer, and you can give certain tools or certain agents access to certain tools that other ones can't have, so that you can actually try to find a source of truth in a very complex, broad system. So there's really clever things you can do like that.
All right. I would love to get us transitioned over to the next presentation and make sure that we get through everything in time. If you keep adding questions to the chat later for follow-up, we can make sure that we can do sort of post-event follow-up as if we don't have time for live conversation. Thanks again, Ben, for your presentation, for going over the bits there. And let's hand it over to Yuki and Daniel.
Yeah, sounds good. Thanks, Kobe. All right. Hi everyone. I'm Yuki. I'm Daniel, and I'm joined by Yuki today. We're going to give a presentation on MLflow tracing. All right. So yeah, I just wanted to start about sort of
So Daniel, do you
explaining
want
what
to share
tracing is.
the do you want to
Sorry?
share the screen, like slide share? Like you're sharing the edit mode. Yeah. Okay,
Ah,
yeah.
okay.
There
There
you
we go. All right. So yeah, I just wanted to go through, what is tracing for people who aren't familiar and sort of why we as MLflow decided to sort of start building this feature over the past, few months. So firstly, tracing is simply just recording the inputs and outputs and, sort of perhaps other metadata of intermediate function executions. So for example, if you run a top level function and it calls like some helper functions along its execution path, tracing provides you a way to sort of understand the function execution throughout the whole chain. You'll see some examples later, and I think in Ben's presentation he sort of showed this UI where there's like a bunch of rows in a UI, and you can sort of see the inputs, outputs, and attributes of all these like sort of function calls. And the reason we started to invest in this feature is because we saw that more people are starting to build with GenAI, and we wanted to build tools to be helpful for that workflow as well. Classically MLflow is built to sort of help people along, deep learning, sort of classic ML workflows. But as GenAI is really starting to come up in popularity, we also wanted to sort of be helpful in that space as well. And how tracing helps with GenAI specifically is that GenAI applications can often be complex. There's so many frameworks now, as Ben showed earlier, just one call to Crew AI can generate like dozens of intermediate function calls, which are generally abstracted away from you as the end user, right? So if something goes wrong in an intermediate step, for example, let's say you have a RAG chain, right? You have the prompt, you have the retriever step, you have, the prompt to the LLM that contains sort of the context as the retriever documents as context. All of these things can, have problems individually. And if you want to have a chance at debugging what went wrong in your chain, you kind of need tracing, right? You kind of need visibility into these intermediate layers. So MLflow really wants to help people build high quality GenAI applications. And of course, observability and debugging tools are going to be a critical part of that journey. So that was a brief introduction. And I'll just go through sort of like the getting started guides. There's links in the slides, but you can check out the official documentation at mlflow.org. There's plenty of tracing getting started resources. But again, as Ben demonstrated earlier, we try to make it as simple as possible for you. For all the integrations that MLflow supports, for example, we have LangChain, Crew AI. I think Yuki will be going through a list of all the integrations we have. Generally, you just need to call the autolog function and then use the package as normal, right? So if you, creating sort of a line graph agent, all you need to do is call mlflow.langchain.autolog before, and then just use langgraph as normal. And you'll be able to generate a trace in the MLflow UI, and if you're using Jupyter Notebook, in the Jupyter Notebook as well. So yeah, same thing with DSPy. Just yeah, very, very simple to get started. And I just want to take you through sort of the UI, how it looks in MLflow itself. Now, just keep in mind that we're still iterating on the UI. This is very much a feature that's still in development. So this is how it looks today, but it might change in the future, as we add features and stuff. So yeah, traces are linked to MLflow experiments. So as when you set your experiment, during your MLflow setup, this is sort of where all the traces are going to go to. Like you can see there's a traces tab in the experiment view. So just click on that, you'll be able to see all the traces generated in that experiment. And what you get in the UI is, sort of a list of all the intermediate function executions. You can see like this nice rendering for chat messages. You're able to see inputs, outputs, attributes, and events, which are all different sorts of things that you can set on your trace when you log them. You also have, as I mentioned, attributes, and there's even some rich rendering for specific span types. So, if you're using LangChain as a retriever, there's, markdown rendering for the documents to make it easy for you to read them. All right, and I think that was it for my part. Just a brief intro on the motivations and the UI. I'm going to pass it over to Yuki now to talk about sort of the ecosystem and sort of where we're going from here.
Sure. Yeah. Thanks for the introduction, Daniel. I'm Yuki. I'm also a core maintainer in MLflow, and I'm working on tracing these days. Yeah, starting from the system. So yeah, when building tracing, there's a lot of GenAI framework these days. There's like always, almost every week, every month pop up a new famous framework. So we added a lot of integration and building a system around MLflow to how to build out like GenAI in the conjunction with all of those great libraries. And in the new release in 220, yeah, it was I think this week. We released two new integrations. One is a Grok. So Grok is a great platform to call LLM in a very efficient way. And the other is Bedrock. Bedrock is a AWS service to basically provide a facility for many LLMs like Anthropic, Cohere. So now we support these two SDKs. So if you have those two libraries in your agent, you can just trace it by just doing like mlflow.grok.autlog, mlflow.bedrock.autlog. So, and we'll be adding more. So if you have any library in your mind, if you want to add, you can always welcome to contribute, but also please let us know. We are trying to make it as wide as possible and then build the ecosystem around us. Okay, could you go to the next slide? Yeah. And we also see a lot of people actually not using frameworks like LangChain or GenAI to get more control on what you do. And we also support that use case. We provide the Python API to instrument your own logic, so your own functions, your own code blocks. So here's a simple example. So we first enable autologging for Anthropic so that we can just conveniently track every LLM calls automatically. But more on top of that, we have some tool definition like get weather and also some parent function run tool agent. So we can use MLflow.trace decorator. So you can just put that decorator on top of the function, and MLflow automatically captures input, output, and latencies or function names, so those metadata, and also handles the caller-callee relationship. So if you have a bunch of caller stack, a bunch of nested functions, MLflow handle this and create a trace like the light one. Yeah, and also was mentioned that MLflow is built on top of OpenTelemetry, which is a industry standard observability spec and APIs. So yeah, it's pretty stable, and it's built on the probably 5 or 6 years ago, so before GenAI's hype. So, and thanks to this foundation, MLflow can actually export traces to many observability services like Grafana, Datadog, New Relic, using the OpenTelemetry as a contract, which enables you to use your existing like engineering observability stack rather than just instead of having new service or new basically you have new service for GenAI specifically. And yep, could you go to the next slide? Yeah, and tracing, as the in the previous demo, we are mainly talking about debugging, but it's not only for debugging. So one use case is evaluation. So MLflow supports evaluation, and you can do LLM as a judge. You can do some metrics if you need custom metric, and if you use MLflow's evaluation feature, it automatically creates traces for model predictions. So in the result, you see that a lot of good answers, bad answers from model. And if you see bad answers, you can dig into the root cause, like some retriever or maybe tool calling, by looking at the traces associated with each result. So this quick video shows like how to check the actual traces. And yeah, this one is pretty complex chain, but yeah, you can see those like retrieve document to, so does my model handle context properly, or many aspect of the agent performance. Okay, could you go to the next slide? Yeah, and also it's also useful for building data sets because traces are essentially logs. So it is pretty common to build data set from the actual production logs. So for this purpose, you can use MLflow.searchTrace API, which basically bulk loads many traces from the backend using some filtering criteria. And for this is a pandas data frame that return from this API with some like renaming. But yeah, essentially we can pull the question response, so input and output for the entire trace, as well as the latency. And the right two column, search query and search result, is basically we can also pull the intermediate input or output. So this is a tool calling input output. We support some syntax to pull those intermediate states from the traces, so we can evaluate the performance in a more granular way. Right, so actually what's next? Right. Yeah, so what's next is, oh, maybe I should do a demo first. Could you go to the next slide and I do the demo? Yeah. To see what.
All right, I think yeah, you can share and then I'll stop.
Yeah. All right, am I sharing the notebook correctly?
Yeah, we see it.
Okay, cool.
But maybe
So,
for the sake of the presentation, can you zoom in just a little bit?
oh yeah, for sure. I just make it large.
Brilliant. Thank you so much.
Okay, thank you. So yeah, this demo is pretty quick, much less sophisticated than Ben's one. So it just demonstrates how tracing works and looks like. So as usual, we associate a notebook to the MLflow tracking server and create an experiment for it. And so this is a live demo, so hopefully it goes well. And yeah, then we enable the Anthropic auto tracing, because I use Anthropic LLM in this demo. So this is also one line call. And here I define the tool calling agent. So it's pretty simple one. It's just a normal React tool calling agent, which basically calls the tool, invoke tools, and based on the result, it acts accordingly. And here I didn't use Unity Catalog, which is my bad, but I think this is a perfect demonstration of how tedious to define every tools in a naive JSON way. So yeah, you define a function, but you also need to convert it to like JSON configuration like this for every function. And Unity Catalog is basically taking care of it instead on behalf of you. So it's pretty convenient. And yeah, so let's run this agent once. So I have a question, what is MLflow tracing in one sentence, and run it. And oops, so we got the exception. But yeah, I think we have a trace in the bottom. So here you can see the inspect the error. So sorry, I made up this error, but basically this timeline view shows where the error occurs. So we can go to this span, and it opens. We have an events tab, which shows exception recorded. Events tab is for any kind of events, so exception is one of it. And we can see the bot request error from Anthropic saying, okay, so max token must be greater than or equal to 1. So when we go back to the input outputs, we actually see the max token is set to -1. So this is the root cause. So we go back to the cell, And here's the ID where I define max token. So I'm changed to the 1000 for demo purpose, and let run it. And hopefully this time it's passed. All right, yeah, cool. So now we got the answer, and we have a inline trace UI in the Jupyter notebook. So we can see the actual response here as well. And you can also go to the MLflow experiment UI by clicking this button. And yeah, so you can see, for example, in here, you can see the nice chat view here, and all the tool definition passed to the agent, as well as actual tool result from here. So here's a tool. I think it uses a search web tool, and it returns a few search results right here. And based on that, model returns the results like this, and it says MLflow tracking, so it's wrong. So we can just dig into the search result as well. Oh, it's actually returns tracking. So yeah, we can do this kind of debugging and inspection to improve the model quality. And in case if you don't want to show this UI always, you can also turn it off by calling MLflow.trace to disable notebook display. So then if you do that, trace is also only logged to MLflow experiment, and it won't be shown in the notebook. Yeah, so that is my quick demo. And Daniel, can you take over the screen again?
Yeah, give me a second.
Yep.
There we go, I think. Oh, wait, there's...
Oh, I
Am
need to
I
stop, I
sharing
guess.
Slack or...
Oh, yeah. Oh, yeah.
Okay.
Yeah, okay. Can you
Okay.
go back to the, oh yeah. So for the work next, so this is what we have today. So the debugging and some evaluation, inspection, data creation, and some production monitoring. But in 2025, what we're planning is a human annotation workflow. So we've had in a lot of use cases, users want to annotate traces, annotate production logs to create a data set or assess the quality. So this is something we want to support solely. And also stronger evaluation integration. So we already support some debugging experiments with evaluation, but we want to make it more stronger and make it more convenient for all of you. And the third part is the end-to-end lineage. So in machine learning, it is very important to have a lineage from the beginning of like training data creation until the production. So tracing is the perfect place to track that lineage. So we're also heading to that direction. And yeah, multimodal, they say a lot of image. There's a lot of great image text model. So we also want to support it. And prompt tracking. So yeah, this is also very common feedback from all of you that we want to manage prompt. So we still have a lot of prompt engineering in the GenAI development. So this is some feature we want to support in 2025. And yeah, lastly, more tutorials and guides. So yeah, our doc, MLflow.org, has many tutorials, but the industry is evolving crazy. So whenever new technology comes in, we want to provide some tutorials guides to make it use it with MLflow in a robust way, with the best practice in MLOps. So yeah, stay tuned. We'll do a lot of development in 2025, and we'll be announcing them in the office server or virtual meeting like this. So yeah, please still stay focused, and we'll share some good news. Yeah. All right, yeah, I think that's all from the tracing part. So
maybe pass back to you, Kobe.
Thank you, fellas. Really appreciate it. We are at about 5 minutes before the top of the hour. So if there are a few quick questions, happy to take them right now for the team. And while you're thinking about those questions, let me go ahead and share the survey link. Survey's really, really quick. Take a moment and just do that. I'll get that screen shared up. And just go ahead and the QR code is there. I'll also paste the link into the chat here, so you have options around how to go about it. But I just would really love to make sure that people have a chance to do that. And so, any last minute questions for the team about what you've seen?
Kobe, I've got a quick question.
Yeah.
Daniel and Yuki, this is actually quite brilliant for the developers. Once you give them the visibility into how things are happening behind the scenes, this is brilliant. quick question is, when you turn on the auto logging, how much visibility, how much control do you have in terms of the frequency of the logging stuff? Does it actually log at every time you call a function, or does it actually do it at the end? In other words, is the logging done in bulk, or is it actually done synchronously or asynchronously?
Yeah, great question, and I think I can take that. So yeah, it is currently done in one by one, and you can also turn on the async mode to make logging asynchronously and in the batch. We're also planning to support make the backend a bit more scalable to support batch logging. So that is on our roadmap. But yeah, currently you can do the sync logging and async logging the client side and control some of the cadence of logging.
And the follow-up question would be, supposing if I actually want to control when I log, because once you turn auto logging, you're actually giving control to the MLflow API, and we just write as soon as we make a call. But what about if I actually want to explicitly say, okay, I'm going to log this and I'm not going to log that? So you turn off the auto logging, but you use the MLflow API to log something. Is that possible with LLM? We used to do that. We used to enable that for the traditional ML APIs. But I'm not sure about the GenAI.
Yeah, so it's definitely possible to do manual logging. I think Yuki showed some short code snippet earlier where you can manually trace things. So you can set the inputs and outputs and
Okay.
attribute. Yeah.
Okay. Good. That's all.
All right. I don't see more questions in the chat right now. One tactical, just logistical bit. We'll make sure to go back to Slack and share the link to the recording of this meetup afterward for that question. And we're really excited about having this series continue going forward. So looking ahead very quickly, want to just again thank you in advance for taking a moment to do the survey. It's very, very short for the meetup survey. The full MLflow user survey that we shared earlier is available. The link is in the scroll back. We can probably paste it one more time. But that survey is a little longer. But please do fill out both of them. We really want to make sure that people are getting their voice heard and what needs to be done and where we want to go. So please do make the moment to do that. Really excited to have that for you. If there aren't any further questions, we are just about at the top of the hour. So please do have any last thoughts or any questions you want to throw out. All right. Well, let's take one last moment. Thank you to Yuki and Daniel for their presentation. Thank you to Ben for his earlier presentation. Really appreciate everybody coming out to this event. We will certainly be back again next month. So thank you very much for keeping an eye out for that. That Luma link, we'll make sure to include all of these links and share them in the Slack environment. So if you want to get back into that workspace to follow up on all of these things, and I heard somebody saying about looking for seeing this chat scroll back, we'll get that logged in and see what we can do for that as well. Make sure everybody can have access to the data for follow-up. And with that, I will close it out. And again, thank you everyone for coming.
Thanks. We'll see you next time.